For as long as humans have existed, sleep was treated as instinct, not as a system, something the body demanded, but science barely questioned. That changed at the end of the 19th century, when modern life quietly began to stretch the limits of human endurance. Factories no longer slept, cities glowed through the night. Shifts extended, deadlines tightened, and for the first time in history, large populations were expected to remain awake far beyond what biology had prepared them for. It was during this period that what we now call sleep deprivation experiments began to take shape, not as dramatic laboratory trials at first, but as observations born out of necessity. Industrial physicians noticed something unsettling in exhausted workers who had not slept properly for days. Their bodies endured, but their minds did not. Confusion appeared before physical collapse. Mood changed before strength faded. Something inside the brain was failing quietly, long before the heart or muscles gave up. At the same time, military institutions were facing a similar problem under far more extreme conditions. Modern warfare required soldiers who could remain alert for nights on end, guarding positions, piloting early aircraft, or operating machinery where a single lapse meant death. Commanders noticed that after prolonged wakefulness, discipline eroded, judgment collapsed, and confidence became dangerously misplaced. Soldiers would insist they were fully capable, even as they made catastrophic errors. This contradiction alarmed doctors more than fatigue itself. Medical science began to connect the dots. Patients in hospitals who were denied sleep, sometimes unintentionally due to pain, light, or noise, showed psychological breakdowns that resembled acute mental illness. Anxiety escalated without clear cause. Thoughts lost coherence. Some patients became paranoid, others emotionally flat. Sleep, once considered passive, was suddenly suspected to be actively protecting the mind. As research became more deliberate, scientists started to distinguish between different forms of deprivation. Some experiments removed sleep entirely, forcing subjects to remain awake continuously. Others allowed brief rest, but never enough to fully recover. A third approach targeted something even more specific, the dreaming phase itself. By waking participants the moment they entered REM sleep, researchers discovered that even when total sleep time seemed adequate, the mind still unraveled in unexpected ways. Yet across all variations, one pattern became impossible to ignore. Complete deprivation, total removal of sleep, produced the fastest and most severe breakdown. It was not gradual exhaustion, it was a cascade. Cognitive control slipped first, emotional regulation followed, and reality itself began to distort. By the mid-20th century, these experiments had grown darker. Reports emerged of participants suffering lasting psychological damage. Some never fully returned to their previous mental state. Others experienced delayed collapses weeks after the experiments ended. In rare cases, indirect deaths occurred, not from lack of sleep itself, but from the accidents, medical complications, and mental crises that followed prolonged wakefulness. Ethical scrutiny intensified. After 1965, as research standards tightened and human experimentation came under global review, sleep deprivation studies became symbols of scientific overreach. What had begun as a quest to understand human limits was now viewed as a warning. The brain, it seemed, was not merely tired without sleep, it was destabilized, and science had pushed far enough to realize that some boundaries, once crossed, could not be safely explored again. The first full day without sleep does not announce itself with collapse or panic. It arrives quietly, almost deceptively calm. On the surface, the body still moves, speaks, and responds. To an untrained eye, nothing seems seriously wrong. But inside the brain, the earliest fractures are already forming. After roughly 24 hours of continuous wakefulness, the brain begins to ration energy. Glucose, its primary fuel, is no longer distributed evenly. The frontal lobe, responsible for judgment, self-control, focus, and decision-making, receives less than it needs. This region does not shut down completely, it weakens, and that difference is crucial. A weakened frontal cortex continues to operate, but without reliability, like a control panel with fading lights. At the same time, communication between key systems begins to degrade. The prefrontal cortex, which normally regulates emotion and behavior, loses its firm grip on the limbic system, the emotional core of the brain. Signals still travel between them, but they arrive distorted and delayed. Emotional reactions become louder. Rational restraint becomes slower. The balance that keeps thought and feeling aligned starts to slip. What follows is not dramatic confusion, but subtle malfunction. Small mistakes appear first. Words are misread. Sentences are skipped or misunderstood. Tasks that were once automatic now require conscious effort, and even then, errors repeat themselves. Attention fragments easily. The mind drifts, snaps back, then drifts again, never fully stable. Perhaps the most dangerous change is the one people almost never notice in themselves. Confidence increases. Not real competence, but a false sense of capability. The brain, deprived of sleep, loses its ability to accurately judge its own performance. Decisions feel correct. Reactions feel sharp. The individual becomes convinced they are functioning normally, even as objective performance steadily declines. This is why researchers compare the cognitive state after 24 hours without sleep to intoxication. Reaction time slow, risk assessment deteriorates, judgment becomes impulsive. In controlled studies, the impairment closely mirrors that of driving with a blood alcohol concentration of 0.1%. Yet unlike alcohol, there is no sensation of being impaired, no warning signal, only the illusion of control. At this stage, the brain has not yet broken. It has merely begun to lie to itself. And that quiet deception is what allows the next phase to arrive unnoticed, carrying consequences far more severe than simple fatigue. By the time the body reaches 36 hours without sleep, the damage is no longer subtle. The illusion of control that dominated the first day begins to fracture, and reality itself starts to lose its sharp edges. This is the point where fatigue stops behaving like tiredness and starts behaving like neurological disruption. Deep within the brain, the temporal lobe begins to malfunction. This region plays a central role in language, auditory processing, and the interpretation of meaning. As sleep deprivation deepens, its activity becomes unstable. Words are still heard, but comprehension lags behind. Sentences are formed, but they arrive incomplete, tangled, or oddly misplaced. Speech slows, then accelerates, then stalls again, as if the mind can no longer maintain a steady rhythm. Visual processing follows a similar path. The brain still receives images from the eyes, but it struggles to organize them correctly. Depth perception weakens, details blur. Familiar objects feel slightly off, not distorted enough to alarm, but altered enough to unsettle. Faces are recognized, yet expressions are misread. Movements are seen, but their timing feels wrong. The world begins to feel unstable, as though it is shifting faster than the brain can track. Psychologically, time starts to dissolve. Minutes stretch or collapse without warning. Events from hours ago feel distant, while distant memories intrude as if they just occurred. This loss of temporal grounding makes planning nearly impossible.
Cause and effect drift apart. The mind reacts to the present moment without anchoring it properly to past experience or future consequence. Language, one of the most complex human functions, deteriorates in a particularly revealing way. Speech becomes fragmented. Thoughts arrive faster than they can be organized or vanish mid-sentence before they're fully expressed. Simple phrases require effort. Complex ideas become nearly impossible to assemble. Yet, despite this internal struggle, many subjects continue to speak with confidence, unaware of how disordered their words sound to others. Decision-making collapses quietly. Choices are made quickly, with certainty, but without logic. Obvious risks are dismissed. Contradictory information is ignored. Participants in controlled experiments often insisted their answers were correct, even when confronted with clear evidence to the contrary. The brain's internal error detection system, normally quick to signal mistakes, has begun to fail. This is what makes the 36-hour mark so dangerous. The individual is no longer merely impaired, but miscalibrated. Their certainty grows as their accuracy disappears. They do not feel confused, they feel decisive. And as the brain continues to operate on diminishing stability, the gap between perception and reality widens, setting the stage for something far more disturbing than poor judgment alone.
At 48 hours without sleep, the brain crosses a threshold it was never designed to approach. What began as fatigue, then instability, now turns into fragmentation. This is the point where the mind no longer fails as a whole, but breaks apart in pieces. The brain, desperate to survive, begins to force sleep upon itself, not in the form of rest, but in brief, uncontrollable shutdowns known as microsleeps. These episodes last only seconds, sometimes less, and often go unnoticed by the person experiencing them. Portions of the brain fall asleep while the eyes remain open, while other regions continue operating as if nothing has happened. Consciousness no longer exists as a single state, it flickers. This internal split creates a dangerous conflict. Systems responsible for perception remain active, while systems responsible for interpretation intermittently disengage. The result is sensory input without proper filtering. Signals arrive without context. The brain begins to fill in the gaps on its own, not through imagination, but through disordered neural activity. Visual hallucinations are often the first to appear. Shadows move where nothing exists. Brief flashes of light appear at the edge of vision. Shapes resemble people, animals, or objects, only to vanish when directly observed. These images are not dreams bleeding into wakefulness. They are the visual cortex firing without regulation, responding to noise rather than reality. Auditory hallucinations follow closely. Soft sounds emerge in otherwise silent environments. Whispers without words, faint knocking, a voice calling a name that was never spoken. The brain's language and sound processing centers, deprived of coordinated control, begin to generate signals internally and misidentify them as external. More disturbing still are the tactile sensations. Many subjects report the unmistakable feeling that someone is nearby, a presence just outside the field of view, a sense of being watched, accompanied by chills or sudden alertness. This phenomenon arises when the brain's spatial and bodily awareness systems desynchronize, creating the illusion of another entity occupying the same space. At this stage, the line between internal and external reality collapses. These experiences are not fantasies, not daydreams, and not products of belief.
Brain imaging and EEG recordings confirm abnormal, localized neural firing patterns during prolonged wakefulness. The hallucinations are real events occurring inside a malfunctioning brain. Once this point is reached, recovery is no longer immediate. Even if sleep is allowed soon after, the nervous system does not simply reset. The brain has entered a state of instability, one where perception itself can no longer be trusted. And as wakefulness continues, that instability does not fade. It deepens, pulling higher functions down with it.
After 72 hours without sleep, the brain no longer behaves like a fatigued system. It behaves like a mind in crisis. What collapses at this stage is not perception alone, but structure. The internal framework that organizes thought, intention, and identity begins to give way. Neurologically, the brain's executive network deteriorates. This network, distributed across the prefrontal cortex and its connections, is responsible for planning, impulse control, and the ability to hold goals in mind while acting toward them. As deprivation continues, these circuits lose coherence. Signals misfire, priorities dissolve. The brain can no longer sequence actions or anticipate outcomes. Behavior becomes reactive, driven by immediate stimuli rather than deliberate choice. Without this executive control, the mind loses its internal anchor. Thoughts arrive without hierarchy or context. Ideas compete instead of aligning. The ability to evaluate one's own thinking, already weakened in earlier stages, nearly disappears. The person may speak, move, and respond, but their actions no longer reflect a stable inner logic. Psychologically, paranoia begins to dominate. The world feels hostile, even in neutral environments. Ordinary sounds trigger fear. Neutral expressions appear threatening. The brain, stripped of its regulatory balance, interprets uncertainty as danger. This fear has no clear source, yet it feels urgent and undeniable. The boundary between imagination and reality erodes further. Hallucinations no longer feel fleeting or questionable. They integrate into the person's understanding of the world. False memories may form. Delusions take shape, often involving persecution, surveillance, or personal significance. The mind stops asking whether something is real and starts reacting as if it must be. Emotional regulation collapses alongside cognition. Some individuals become aggressive, responding to minor stimuli with disproportionate anger. Others withdraw completely, retreating into silence, immobility, or emotional numbness. Both responses stem from the same failure, the brain's inability to manage internal stress while remaining connected to reality. Clinically, the resemblance to acute psychosis becomes unmistakable. In controlled settings, neurologists have compared brain activity at this stage to that observed in patients with schizophrenia during active episodes. The similarity is not metaphorical. Functional breakdowns overlap. Neural communication patterns align. The difference lies only in duration. This is why the 72-hour mark is considered one of the most dangerous points in sleep deprivation research. The mind has not simply lost clarity, it has lost coherence. Identity begins to fracture, not through memory loss, but through the collapse of the systems that define what is real, what is imagined, and what belongs to the self. At 96 hours without sleep, the situation becomes a neurological emergency. The brain is no longer deteriorating gradually, it is failing in waves. What remains of organized mental function exists only in fragments, separated by gaps of confusion, emotional instability, and loss of self. Emotional expression breaks free from meaning. Laughter erupts without joy. Crying begins without sadness. These reactions do not correspond to thought or memory.
They emerge directly from unstable neural circuits. The limbic system, overwhelmed and unregulated, fires unpredictably, while the cortical systems that normally interpret and restrain emotion can no longer intervene. Basic biological signals also begin to vanish. Hunger fades, not because the body is nourished, but because the brain can no longer register internal cues correctly. This loss is dangerous. Blood sugar can drop unnoticed, pushing the body toward collapse while the mind remains unaware of the threat. The instinct to eat, one of the most fundamental survival drives, simply goes silent. Memory disintegrates further. Some individuals forget their own names. Others cannot recall personal history, relationships, or where they are. Identity, once eroded by confusion, now dissolves outright. Faces lose familiarity. Loved ones appear as strangers. The brain's facial recognition systems, tightly linked to emotional memory, no longer communicate effectively. Recognition becomes mechanical, then disappears entirely. Medically, this stage is defined by a catastrophic breakdown in communication between the cerebral cortex and the limbic system. Rational processing and emotional response operate in isolation, no longer synchronized. The brain, sensing unsustainable instability, begins shutting down non-essential functions in an attempt to preserve life. These are not conscious decisions, but emergency responses driven by survival circuitry. Sleep deprivation research describes this phase as one of protective collapse. The mind sacrifices higher functions, identity, emotional regulation, coherent memory, in an attempt to prevent total systemic failure. The result is a person who is awake in body, but no longer fully present in mind. Nathaniel Kleitman, one of the pioneers of sleep research, described this stage with unsettling precision. He did not speak of tiredness or confusion. He wrote simply that the mind begins to disintegrate, and by 96 hours, that disintegration is no longer theoretical. It is visible, measurable, and terrifyingly real. At 120 hours without sleep, the experiment is no longer an experiment. It becomes a crisis that cannot be ethically sustained. This is the point at which researchers stopped, not because curiosity was satisfied, but because the mind had crossed into a state from which recovery was no longer guaranteed. Full psychosis emerges, not intermittently, not in flashes, but as a continuous condition. Hallucinations no longer fade in and out. They persist, layering themselves over waking reality. Voices may speak without pause. Figures appear and remain. Delusions harden into belief systems that resist correction. The brain no longer questions what it perceives. It accepts it. Behavior grows unpredictable and dangerous. Some individuals attempt to flee imaginary threats. Others become aggressive toward people they believe intend harm. Instructions are ignored, not out of defiance, but because the brain can no longer process them as meaningful. Language loses authority. Reality loses coherence. The individual is no longer reachable through reason. Physiological systems begin to destabilize as well. Blood pressure can drop suddenly, sometimes without warning. The autonomic nervous system, already strained beyond its limits, struggles to regulate heart rate, circulation, and temperature. The risk is no longer psychological alone. The body itself begins to fail under the weight of prolonged neural chaos. This is why experiments were halted at this threshold. Beyond this point, sleep deprivation no longer reveals how the brain functions without rest. It reveals how the brain breaks. Medical teams observed that even when sleep was finally restored, recovery was slow and uncertain. Some participants required weeks or months before basic cognitive stability returned. More disturbing were the cases that never fully resolved. Long after sleep patterns normalized, traces remained: persistent anxiety, emotional blunting, fragmented memory, altered perception. The deprivation had not simply exhausted the brain, it had injured it. By 120 hours, the human mind demonstrates a final truth that research could not ignore. Sleep is not optional, and when it is withheld long enough, the cost is not fatigue, but sanity itself.
Among all documented cases of extreme sleep deprivation, one experiment stands apart, not because it was the longest, but because it was the most closely observed. In 1964, a 17-year-old student named Randy Gardner volunteered for a study that would push the human brain far beyond its natural limits. He stayed awake for 11 consecutive days. No stimulants, no drugs, no artificial interventions to keep him conscious beyond constant monitoring and conversation. Unlike earlier experiments, Gardner's deprivation unfolded under medical supervision. Electroencephalograms recorded his brain's electrical activity. Memory tests were administered daily. Psychologists evaluated his mental state hour by hour. What they observed was not a slow decline, but a layered collapse, unfolding differently each day. As the days passed, his cognitive abilities unraveled in ways that defied intuition. His memory fractured first. Short-term recall became unreliable, then nearly impossible. Simple tasks demanded intense effort, and even then, errors multiplied. At one point, Gardner could no longer count backward correctly or perform basic arithmetic. Numbers, once automatic, lost their internal structure. Perception followed. Gardner began seeing things that were not there: signs, objects, patterns appearing in empty spaces. These were not vague impressions, but detailed visuals his brain insisted were real. At his most unstable moment, he became convinced he was a famous American football player, adopting an identity that had no connection to his own life. The delusion was complete, held with confidence and resistant to correction. What made this case especially unsettling was that Gardner remained outwardly cooperative. He spoke calmly, he answered questions, he appeared functional to casual observers. But the data told a different story. EEG recordings showed abnormal patterns consistent with localized sleep intrusions. Parts of his brain were shutting down briefly while others remained active, creating a fractured state of awareness that mimicked psychosis. When the experiment finally ended, Gardner was allowed to sleep. He did not collapse instantly. He slept longer than normal, but not excessively. Within days, most of his physical symptoms faded. Medical examinations suggested his body had survived the ordeal without permanent damage. But time revealed a deeper cost. Although Gardner regained cognitive stability, his sleep was never quite the same. For years afterward, his sleep patterns remained altered, lighter, more fragmented, more vulnerable to disruption. The brain had recovered, but it had not forgotten. The significance of the Gardner experiment lies not in how far he pushed wakefulness, but in what it revealed about recovery. Even under controlled conditions, even with youth on his side, even with constant medical oversight, the brain paid a lasting price. It demonstrated that extreme sleep deprivation does not always leave visible scars, but it leaves marks nonetheless, written quietly into the architecture of the mind.
To understand why the brain collapses without sleep, it is not enough to describe what fails. We have to understand what sleep is actually doing, not as rest, not as inactivity, but as one of the most complex biological processes the human body performs. When the brain enters sleep, a system rarely active during wakefulness comes online. Known as the glymphatic system, it functions as a cleansing network, flushing metabolic waste out of brain tissue. During the day, Neural activity produces toxins as a byproduct of thought itself. These substances accumulate silently between neurons. Sleep expands the spaces between brain cells, allowing cerebrospinal fluid to wash through and carry these wastes away. Without this process, toxins build up, interfering with signaling and accelerating cognitive breakdown. Sleep also recalibrates the brain's internal wiring. Every waking hour strengthens some neural connections and weakens others. Without periodic reset, this system becomes saturated. During sleep, particularly deep sleep, the brain selectively trims and stabilizes synaptic connections, preserving what matters and discarding what does not. This is not memory loss, it is memory refinement. Without it, neural circuits become noisy, inefficient, and unstable. Hormonal balance depends on sleep in equally critical ways. Stress hormones rise and fall in response to circadian rhythm. Growth hormone, essential for tissue repair and metabolic regulation, is released primarily during deep sleep. Disrupting this cycle shifts the entire endocrine system out of alignment. The result is not immediate collapse, but gradual systemic stress that compounds over time. Memory consolidation is another silent function of sleep. Experiences are not stored permanently at the moment they occur. They are replayed, reorganized, and integrated during sleep, particularly during REM stages. Without this process, memories remain fragmented and unreliable. Learning slows, emotional experiences lose context, the past becomes unstable. When sleep is withheld, the brain attempts to compensate, but its chemistry turns against it. Adenosine, a molecule that signals fatigue, accumulates continuously during wakefulness. Under normal conditions, sleep clears it. Without sleep, adenosine builds to toxic levels, suppressing neural activity and distorting perception. The brain becomes chemically overwhelmed. Electrical stability also deteriorates. Neural firing patterns lose synchronization. Regions activate out of sequence or fail to deactivate when needed. This electrical noise contributes directly to hallucinations, emotional dysregulation, and cognitive collapse observed in prolonged deprivation. Beyond the brain, the immune system weakens dramatically. Research shows that extended sleep loss can reduce immune effectiveness by up to 70%. The body becomes vulnerable to infection, inflammation increases, and recovery from injury slows. Sleep deprivation does not isolate itself to the mind, it destabilizes the entire organism. Sleep, then, is not a pause in biological function. It is maintenance, it is repair, it is regulation. And when it is removed, the brain does not simply become tired, it becomes unprotected.
The question has been asked repeatedly, often with unease and disbelief. Can lack of sleep actually kill a human being? The answer, at first, seems reassuring. Sleep deprivation does not function like poison. There is no fixed number of sleepless days after which the body simply shuts down. Death does not arrive directly from wakefulness alone. But this reassurance is dangerously incomplete. Prolonged sleep deprivation dismantles the systems that keep a human alive. As cognitive control erodes and physiological regulation destabilizes, the risk of fatal outcomes rises sharply. Judgment collapses, reaction time slows, perception distorts. The likelihood of catastrophic accidents increases dramatically. Fatal crashes, industrial disasters, lethal mistakes that occur not because the body failed, but because the brain misfired at the worst possible moment. Inside the body, stress hormones remain elevated without relief. Blood pressure regulation becomes erratic.
In vulnerable individuals, this strain can trigger strokes or heart attacks, even in the absence of prior disease. The nervous system remains locked in a state of emergency, exhausting itself until failure becomes statistically inevitable. The psychological danger is just as severe. Sleep deprivation intensifies despair, impulsivity, and emotional instability. In some cases, it pushes individuals towards self-harm. The risk of suicide rises sharply as the brain loses its ability to regulate mood, evaluate consequences, or perceive hope accurately. What feels permanent in a sleep-deprived mind may have been temporary if rest had been allowed. There is, however, one condition where sleep loss itself is lethal. Fatal familial insomnia is a rare inherited neurodegenerative disease that destroys the brain's ability to initiate sleep at all. It is not a disorder of will or behavior. The brain simply loses the capacity to enter restorative sleep. As months pass, the patient experiences progressive insomnia, followed by hallucinations, autonomic failure, and rapid cognitive decline. There is no cure. No treatment can restore normal sleep. Within 12 to 18 months of onset, the condition leads inevitably to death, not from exhaustion alone, but from total neurological breakdown. The brain cannot survive without the process it was built around. Sleep deprivation may not kill quickly, and it may not leave a clear cause on a death certificate, but its consequences are lethal by design. The body survives moment to moment, while the systems that protect life quietly fall apart.
As sleep deprivation entered public imagination, one story rose above all others, spreading across forums, videos, and whispered retellings as if it were forbidden history. The so-called Russian sleep experiment claimed to describe a secret Soviet study in which subjects were kept awake for days under sealed conditions, descending into madness and violence. It sounded scientific, it sounded plausible, and that is precisely why it worked. But when examined carefully, the story collapses. There is no source document, no published paper, no laboratory records, no institutional affiliation, no named researchers, no test subjects, no dates, no archived materials in any scientific or governmental database. Not in Soviet records, not in declassified archives, not in medical literature from any era. For an experiment allegedly conducted at the height of Cold War secrecy, it leaves behind an impossible absence of evidence. Real sleep deprivation research, even the darkest chapters of it, left traces, medical notes, ethical reviews, censored publications, testimonies. The Russian sleep experiment leaves nothing. It exists only as a narrative, retold and embellished, with details that shift subtly each time it is repeated. Yet the story's power lies in its use of genuine neuroscience. It borrows real concepts, hallucinations, paranoia, cognitive collapse, and exaggerates them into horror. It mimics the structure of legitimate experiments. It echoes authentic symptoms documented in real cases. This blend of truth and fiction is what made it so convincing. The human brain recognizes familiarity before it recognizes accuracy. When a fictional account aligns closely enough with known scientific facts, it bypasses skepticism. Millions accepted the story not because it was proven, but because it felt possible. The danger of the Russian sleep experiment is not that it is false, it is that it distracts from reality. The true history of sleep deprivation is not a hidden conspiracy or a monstrous legend. It is documented, measured, and in many ways more unsettling than fiction. Real experiments showed that the brain does not need sealed chambers or secret gas to collapse. It needs only time without sleep. What makes the Russian story unnecessary is this simple fact. Reality went further, and it did so in plain sight.
Long before internet legends, real institutions conducted sleep deprivation experiments whose consequences were documented, not imagined. In the Soviet Union, researchers explored the effects of isolation combined with prolonged wakefulness, often removing light, sound, and social contact simultaneously. Subjects were placed in controlled environments where time cues vanished. Within days, psychological collapse followed. Disorientation came first, then anxiety, then breakdown. These studies were not rumors, they were published through institutions such as the Pavlov Institute, framed in clinical language that barely concealed the severity of what occurred. The results were consistent. When sleep deprivation was paired with isolation and darkness, the mind unraveled faster than expected. Hallucinations emerged early. Emotional regulation failed rapidly. Even after sleep was restored, many subjects displayed lingering instability, suggesting that deprivation did not merely exhaust the brain, but altered it. Military research reached similar conclusions under different pressures. Pilots, especially during early jet aviation and long-range missions, were pushed beyond safe wakefulness limits. The assumption was that training and discipline could overcome biology. It could not. Reaction times slowed imperceptibly, then catastrophically. Navigation errors multiplied. Judgment failed at altitude. Accidents occurred not because machines malfunctioned, but because the brain did. Entire flight doctrines were rewritten after investigations traced fatal crashes back to sleep-deprived decision-making. In the United States, the boundaries were pushed even further during the Cold War under programs like MK Ultra. Sleep deprivation was combined with psychoactive substances, including LSD, in an attempt to dismantle identity and resistance. Subjects were kept awake for extended periods while their perception was chemically distorted. The result was not control, but damage. Some individuals experienced permanent psychological fragmentation, memory loss, dissociation, and inability to return to a stable sense of self. These were not side effects, they were outcomes. Even within clinical psychiatry, sleep deprivation was once explored as a treatment. Patients were deliberately kept awake under the belief that exhaustion might reset certain mood disorders. In the short term, some symptoms appeared to improve, but the cost became undeniable. Prolonged wakefulness triggered acute psychosis, intensified paranoia, and worsened long-term outcomes. The practice was abandoned when it became clear that the harm outweighed any temporary benefit. These experiments were not secret myths or lost files. They were conducted by respected institutions, justified by scientific curiosity, military necessity, or therapeutic hope, and they all reached the same conclusion. The human brain does not negotiate with sleep deprivation. It does not adapt. It does not harden. It breaks, predictably, measurably, and often irreversibly.
All of this evidence leads to a conclusion that science rarely states outright, yet never contradicts. Sleep is not rest in the casual sense. It is not a pause, not a luxury, and not time stolen from productivity. It is a biological safety system embedded into the brain as deeply as breathing itself. The brain does not endure prolonged wakefulness as a challenge to overcome. It interprets it as a threat. Every hour without sleep increases instability, not gradually, but structurally. Systems designed to regulate emotion, perception, memory, and identity begin to fail in a predictable order, as if the brain is shedding higher functions to preserve survival. What these experiments reveal is not human weakness, but human design. The brain was never built to stay awake indefinitely.
It has no backup mode, no emergency override. When sleep is denied long enough, reality itself becomes negotiable, then unreliable, then unreachable. Sleep deprivation does not announce madness with sudden collapse. It dismantles the mind piece by piece, while the individual remains convinced they are still in control. That illusion is its most dangerous feature. The science is unambiguous. The fastest path to losing reason is not trauma or intoxication or disease. It is sustained wakefulness. And the moment sleep is removed, the countdown has already begun.